point do you kind of become the super dad and decide to take on this quest to diagnose her yourself?
Well, it took about 6 months to figure out definitively that she didn't have Loeys-Dietz, because even though the echo was telling, there's always some clinical variability. So Bart actually sequenced the 2 genes that are responsible for that, and they were normal. So that almost certainly excluded that diagnosis, although as it turns out, those aren't the only genes that give rise to Loeys-Dietz. But so the next year, I just studied the biochemistry that's associated with those particular. So that those genes code for growth factor receptors, and it turns out that not very much was known about it. And most of the work had been done in the early '80s, and it was sort of crap work, to be honest with you. It's sort of the easy, low-hanging fruit of TGF-beta receptors, and so. And the field basically thought they knew everything there was to know about it and kind of moved on. But about a year later, after studying TGF-beta, I had a hypothesis that maybe another set of receptors that are very closely related might be affected, because those receptors were for a protein that regulated muscle. And B's primary problem at age 3 going on was actually she didn't have enough muscle. She had about half the normal amount of muscle, so she was weak and a little bit low tone. And I was very fortunate. I had a friend at Hopkins who was a grad student when I was there who had discovered that protein. And so I called him up and I said, have you ever heard of any mutations in the receptors for myostatin, which is the name of the protein? And he said, no. And he said, but it doesn't sound like a bad hypothesis. And I said, well, you sequenced the genes for me. And he said, no, I can't do that. I don't have an IRB approval, and I just can't do it. And so I did it myself.
So how do you go about doing that? How do you sequence the genes yourself?
Well, I had sequenced a lot of genes, just by hand, in the lab in the old days. And so the way you do it is you call up some company. In this case, it was IDT in Illinois, and you order the primers, and they send them to the Institute for Further Study at 2729.
Which is your house, yes.
And you put all the reactions together, and I went down to a friend of mine at Stanford, and I said, can I borrow your lab for an afternoon? And boom, do that, and then I sent them off to a university hospital, and they did the rest of the work, and then they sent me a file at home.
Yes, and this is what sticks out in my mind, is going up to your attic office and just, after you put the kids to bed at night, you would go up there for hours and look at tens of thousands of nucleotides every night, looking for that one mutation that might be at the root of what's wrong with you.
Right. I mean, I figured it had to be, because all of those diseases are a single nucleotide change on just one chromosome, so I figured it had to be a dominant. I figured it had to be a simple mutation. And I was deathly afraid of missing it, to be honest with you. So I sequenced, back and forth and duplicate and everything, and so it was about 20,000 base pairs of DNA. And of course, I didn't have any software. I used Word to do the analysis, because I would take the GATs and Cs and I'd put them in and say find this sequence.
Right.
And if it found to try to find differences.
So Control F was your friend in doing all this.
Yeah. So.